today we're gonna visit Warsaw to discuss about sort of the research that's happening there. In particular, we're gonna go to the University of Warsaw, and we have Ewa Turek, if I'm pronouncing your name correctly. Sorry, it's really hard for me to pronounce Polish names. And Piotr Milosz and Łukasz Kwieciski. And I'll let first Ewa present the group and the university.
Okay, thank you very much. Let me share my screen first. So do you see the screen?
Yes, that's all good.
Okay. So first of all, thank you very much for this introduction, and thank you very much for inviting me to give this short presentation. So it's going to be about the area of my research group, which is machine learning, mostly in computational oncology. So we are working on method development mostly in statistical data analysis, probabilistic graphical models, which I will skip for this presentation, machine learning and deep learning. And it's always at the service of what I think is an important cause, which is computational biology with a focus on computational oncology. And if you're interested in the details, this is the link to our website presented on the slide. So our research questions are always concerned with how to model and understand better and different aspects of research in computational biology oncology. So it's either high-dimensional experimental medical data, which we worked on in previous years, as sensitivity to cancer of cancer cells to drugs, which is more of a recent project. We also work now on analysis of medical images, generation and modeling of antimicrobial peptides. We also have actually 4 people in the group that model tumor evolution and the microenvironment. And very, very recently, I myself got involved in modeling COVID-19 spread in the population of Poland and also of Germany. So I guess more interesting for the audience of this conference is this method development in the area of deep learning. So this is a very brief overview of the projects that we are involved in now. We are working on development of convolutional neural networks and active learning for a classification of histopathological images. So we published this method called ARA-CNN in Scientific Reports last year. And this year, we are very, very actively working on autoencoders-based methods that I will describe in a moment, and on a actually very new model, which is based on conditional variational autoencoders for generation of peptides that can kill bacteria, so can replace antibiotics. So now, very, very briefly, I will describe an example PhD project that is performed in my group. The one which is focusing on drug sensitivity prediction. So the first paper of the PhD student, Krzysztof Koras, was about feature selection strategies for drug sensitivity prediction, and that was mostly based on classical traditional machine learning methods, models that were built separately for each known cancer drug. Well, not all known, but the ones that we had data for, and exploiting different feature selection strategies. And now we look at this problem in the second project from a completely different perspective. As this is more multitask learning problem, where we have for all our 74 drugs And for almost 1,000 cancer cell lines, we have this outcome as a matrix. The outcome is the sensitivity measure called either AUC or IC50. And we have additional information both about the drugs, so how strongly they inhibit different kinases, and the cell lines. So we have their tissue type, coding variants, which is the mutations, mRNA, which is gene expression. And in a very, let's say, classical approach, this problem was solved by linear transformation, so linear projections of these high-dimensional features into lower dimensional space, and then simply taking a dot product to obtain these sensitivity measures. But we solve this, I think, in a much more general manner. So we use autoencoders both for drug information and for cell line information in order to project or embed these highly dimensional features into lower dimensional space. We can show that these low dimensional representations are actually very meaningful, so they convey a lot of information about the original space. And then we concatenate these features and then actually use a forward network, so highly nonlinear mapping into the outcome. So this will be submitted in fall, and then the final project of the students will be to actually move to generative models. So hopefully we will be able to generate drugs which have high sensitivity for cancer cell lines. And so I cannot make the presentation about the group without, first of all, mentioning the group members and collaborators. So these are the PhD students, external collaborators, and the master student. And then we have the collaborating labs and the funding. And finally, I want to mention that there will be a postdoc position available in my group. So if you're interested, please apply at this email. And thank you very much. If you have questions, please email at this address. Thank you very much.
Thank you. Awesome presentation. Yeah, quite interesting stuff. And then I would also let Piotr present a little bit his group and research.
Okay. Thank you.
Can you go present?
Yes, I'm doing now. So can you see this?
Yes.
That's why I'm present. Okay, is it fine now?
Yes, yes.
Okay, cool. So first of all, thanks for introduction. And so a few words about us. So we are a group which try to, from the organizational point of view, to maintain many connections. So here I just give you logos of a few institutions. So clearly we are linked with University of Warsaw, and technically we are based in the Institute of Mathematics, Polish Academy of Sciences. We also maintain some links with business. So here I mentioned this company DeepSense AI, which actually we do some project with. Also, I just for the purpose of clarity, I put this red logo of NCN, which is also a source funding. Here's my webpage. We will shortly have a group webpage, but it's unfortunately not present yet. So we call ourselves our lab because we focus on reinforcement learning, on which I will talk tell shortly. From the community perspective, we hold a seminar which we kindly ask to attend, and I think it's a nice option, especially now when everyone can join remotely. We have also reinforcement learning course, which was, I mean, this year it's really finished, but we hope to hold it again then next year. And like this year, it was also possible to attend remotely, so it might be a nice option. So the core of the group is two senior researchers, myself and Łukasz, who is on the call. We have 3 PhD students, 1 postdoc, and I should also mention that there are a number of people in Warsaw doing similar stuff, which we are collaborating with, which are not technically part of our group, but we still think of our extended group. Okay, so I guess you know a little bit about RL, so I just briefly recap over slides which tell that okay, so reinforcement learning is a stick and carrot technique, and which brings a promise that useful behaviors can be learned by trial and error method. And an agent who is learning does this only in receiving rewards, which is carrots, and like sticks, which is punishment. So here's like very shortly, we have an agent environment, and agent issues actions towards the environment that they are executed. Then it observes what has happened, and what is most important here, it obtains rewards. So why we do this? I mean, we think it's cool, and there are also quite a few spectacular successes, like Alpha Star, Dota, Hide and Seek, and so on and so forth. And we have also our local successes. So I will just briefly, list them here. So it's I'm not sure if I should go over all the lists. You can see them later on, but we have some works like working in a robotic setting, working with language, working with autonomous driving. And maybe I should say maybe a few more words about this work, which is model-based for Atari, which is probably for us the most high-profile work we've done so far. So it's like the aim of this work was to make reinforcement learning more sample efficient, meaning that it could learn more with less data. And how this can be done? Obviously, there are many ways which we think of and people have tried. So in this case, what we did, we gave our agent possibility to learn the model of the world, in a sense what can be maybe said as an imagination. So instead of executing an action or a series of action, an agent can first ask the model, or what is it in its head, what will be the future, and taking this information into account, it can adjust its behavior. Okay, and I think my time is over now. So thank you for your attention. I'd be happy to take questions, but I guess Razvan will manage that.
Yeah, thank you both. Yeah, those are quite interesting research. So I think what we're going to do is, with your approval, we can put the email address on the chat where all the participants